calculating moles in mole concept. How do we calculate the number of moles? So there is a simple formula for this, that is amount in moles is equal to mass of the substance in grams, mass of the substance, everything is in grams, correct, divided by our molecular mass, divided by the mass MR or AR respectively. Clear? Or else there is one more triangular formula which I'll be showing to you. So everything if you express in triangle, it's very easy for us to remember. So for MR or AR is nothing but our formula mass respectively. So we'll be drawing this triangle. So mass of the substance is equal to amount in moles. There is number of moles, and this is our MR or AR. There is relative formula mass respectively, which will be given in the question. Or else this is the mass of 1 mole. Which one? This particular thing is the mass of 1 mole. This is the mass measured in grams. This is my mass measured in grams. And this is the number of moles respectively. Correct? So this is basically our formula triangle for moles, mass and formula mass. Now coming back to this, calculating the moles. So for that I'll draw a basic table. Substance, mass, MR, the molecular mass or molecular ratio, whatever it is. This is the amount. So if I am taking sodium hydroxide, NaOH, the mass is what given as 80. Okay, MR is 40. So what is the amount in moles? This is amount in moles. That is nothing but 80 by 40. That is nothing but 2 moles respectively. That's all. Suppose we are taking calcium carbonate. The mass is always in grams. Okay, this is always in grams. Given is 25 grams, they are given. This is 25, everything is in grams. MR is given as 100. CaCO3, it is 100 actually. Correct? So what do? We do 25 by 100 respectively in this. So we'll get 1 by 4, that is nothing but 0.25 moles. Let's take a simple example for us to understand much better. H2O. Okay, if it is given 180 grams here. And what is the molecular mass of this particular thing or formula mass? 18. How we are getting these things? Oxygen is 16, hydrogen is 1 into 2. So totally we are getting 18 here. Correct? So 180 by 18. So that is thing about what? 10 moles respectively. So this is how we calculate the number of moles. The next topic for us, calculating mass. So always remember to draw what? Our triangular thing. Small triangle always for everything we have to draw. So mass will always come on the top. Correct? And this will be our number of moles. And this will be my formula mass. So mass is equal to number of moles into formula mass. Formula mass. That's it. MR or AR or whatever we can take. Or this particular thing. So for this also I'll draw a table. So since water is the most easiest thing, I'll do that thing first. So again, same thing, substance, then the amount of moles, then the MR. Let's take water itself. Important in the sense here I'll write in bracket number of moles. Okay. So here I'll write 0.5 moles. So MR is nothing but what? We all know MR of the water, that is 18 respectively. So if I'm calculating mass, so what is mass? Mass is nothing but this into this. So half, 0.5 is nothing but half. So 0.5 into 18. So 0.5 into 18. That is 1 by 2 into 18. That is nothing but 9 grams. So mass will be always in grams. So that's how we identify these things. Clear? Sodium chloride. Let us take sodium chloride, NaCl. Fine. Molecular mass of that, 58.5 to be accurate. And moles if I'm giving it as 2 moles. So which means I have to multiply 2 into 58.5 respectively. So that will be my answer. So 59 2s are, it will be 118. I have to just subtract 1 from that. It will be 170 grams. Everything is in grams. So this is a basic idea of calculating mass. The next one, calculating relative formula mass. Okay. So this is a very easy thing. This is. So again, we have to draw a triangle. Don't forget this triangle. This is our basic key for remembering any formula. So why I'm drawing again and again is then only will be used to this. Mass in grams will also always be in the top. Then bottom, it will come number of moles. Correct? Then our formula mass. Fine. Yeah. So what is calculating relative formula mass? It is mass by number of moles. Mass by number of moles. So in this particular thing, if I give you one question, okay, the question should be like something like, if 10 moles of carbon dioxide has a mass of 440 grams, what is the relative formula mass? Always remember the triangle. So first thing, even though we know the solution, relative formula mass is equal to, write down the formula. If you've seen for the first time, always write down the formula. That is mass is on the top of the triangle, mass by number of moles. Correct. So mass is always in grams. So 440. Number of moles, 10 moles. So we'll get very easily as 44 as the answer. That is my relative formula mass of carbon dioxide. Fine. The next kind of problems which can come is to calculate the percentage composition. So suppose the question which we get now here is calculate the percentage of oxygen and carbon dioxide. Carbon dioxide. This is the question we are getting. First step. Step 1 for us should be what? What is the molar mass of the carbon dioxide? So carbon we know it is 12 plus oxygen is what? 16 into twice. So we'll get 44. But here the question is what? The percentage of oxygen in carbon dioxide. So how many molecules of oxygen are there? 32 are there. So total mass is how much? Total molar mass of carbon is 44. So if I'm calculating the step 2, I'll directly come to that. If I'm calculating the percentage of oxygen is 2, correct? In carbon dioxide, what should I do? Out of this 44, correct? 32 are occupied by what? Oxygen itself. So into 100. So you'll get around 72.7%. That's all. This you have to put in a box. So if it is carbon monoxide, then things will be different here. So it will be a different thing altogether. So like that, if we can make questions in this, it will be very easy for us to solve. Now, as far as our next topic is concerned, calculating the moles. Or let's take in solutions. Calculation of solutions. There is moles, concentration, and volume. Fine. So let's take the general equation in this. Okay. So concentration, that is mole per decimeter cube. I'll tell you why the formula is like that. Concentration. Because it is moles divided by volume. That's it. So volume is always expressed in centimeter cube or decimeter cube, whatever it is. So how can I write it properly? Amount of substance. That is my mole. To the volume of the solution. That is my decimeter cube respectively. That's all. So from this equation, so we know what will come on the top, correct? So again, what did you do? We have to form a triangle. So here also, I'll explain you based on triangles. Calculating moles, but this is based on concentration and volume. Okay. So first step for us is draw the triangle for us. But here on the top, what should I get here on the top? According to this, moles by volume. So moles is on the top. So I just write what? Moles here. Amount of substance. Correct? And here I can write concentration. And here volume respectively. So calculating moles, moles is nothing but what? Concentration into volume of solution. Into volume of the solution. Always remember the triangle. The next part. Calculate the moles of solute dissolved in 2 decimeter cube of a 0.1 mole per decimeter cube solution. So how do we go forward with these things? So calculate the moles, correct? So we know the formula to use is this particular thing. Dissolved 2 decimeter cube. Decimeter cube means volume. Concentration also given 0.1. Correct? So what did you do in these things? Just multiply 2 into 0.1. That is 0.2. That's it, 0.2 moles respectively. Next type of question which can come is calculating concentration. So again, what do you draw? We draw the triangle. Always for every question, draw the triangle and keep. And on the top, moles should come. Correct? This side concentration. And this time the volume. Volume, how do you identify? It is always in cube. Moles will give moles. Concentration, that is moles per decimeter cube or centimeter cube or whatever they will give you in this. So let's take an example of the same in this. "25 centimeter cube of 0.050 mole per decimeter cube sodium carbonate was completely neutralized by 20 centimeter cube of dilute hydrochloric acid. Calculate the concentration in mole per decimeter cube of the hydrochloric acid. So here, let's read the question one more time. 25 centimeter of 0.5 mole per decimeter cube. Centimeter cube in the sense volume. This in the sense concentration of sodium carbonate is completely neutralized by 20 centimeter cube of diluted HCl. So again here volume they given. Calculate the concentration mole per decimeter cube of the hydrochloric acid. Fine. So first thing for us is we have to find what? The number of moles of sodium carbonate, because they're given the volume and they're given the concentration. First step for us. Step 1. Since they're given everything, we will find the what? Number of moles or the amount of substance. Of sodium carbonate. So just multiply 25 into 0.050. That's it. Correct? But since it is coming centimeter cube, correct? We have to convert centimeter cube to decimeter cube. For that, I'll write down one formula. Centimeter cube to decimeter cube. Correct? We have to divide by 1000. Divide by 1000 to convert centimeter cube into decimeter. So for here also I'll divide by 1000. Hence I'll get the answer as 0.00125 mole, because it is moles or amount of substance. Correct. Now coming to the next part. Completely neutralized by what? 20 centimeter cube of diluted HCl. Calculate concentration in mole per decimeter cube of what? Hydrochloric acid respectively. So how do we do this particular thing? So it took around how many moles? 0.00125 mole. So next thing is we have to calculate the amount in moles for the hydrochloric acid reacted. Correct? So how do we do that further? So step number 2 here. So it's very clear for us that sodium carbonate and HCl reacts to form sodium chloride. Correct? NaCl. But here it is, since it is Na2 and here it is what? HCl. This is not matching. So I have to put what? 2 here. So here it will be what? 2. So what we can infer from, or what we get from this step is nothing but 1 mole in the sense amount of substance, that's it. 1 mole of sodium carbonate reacts with 2 mole of HCl. So what is their molar ratio? There is a term called molar ratio. It is 1:2 between these things. 1:2 respectively. So from the last one, I got what? 0.00125 mole. Correct. So if it is 0.00125 mole, so if it is 0.00125 mole, react with how much? Mole of what? Sodium carbonate. Okay. React with double of that thing. Correct. React with, it is twice. So 0.00 to 125 double is 250 moles of HCl respectively. But still we are not into the answer. Our question here is what? Calculate the concentration moles per decimeter cube. Concentration moles per, now we got the moles. Correct? We got the moles value. Decimeter cube. But again here 20 centimeter. So volume of HCl. So centimeter to decimeter divided by 1000. Centimeter cube to decimeter cube. Divide by 1000. So here also volume of HCl is given as what? 20 centimeter cube. So to convert this in decimeter cube, I should do as what? 20 by 1000 respectively. I'll get decimeter cube. Now if I want to find the concentration, the formula is very simple, that is moles by volume. So moles I got it as 0.00254 and volume I got it as 20 by 1000 respectively. Hence if this goes to the top, just cut this and this. So 0.00250 into 100 by 2. Correct? So since this is the last zero, I can just cut this thing. 25, I can just cut it. So if I put the 2 zeros, this will be shifted. It will be 0.25 by 2. So this is nothing but 0.25 is nothing but 0.250 by 2. That is 0.125. But don't forget to put mole per decimeter cube. That's all. So our concentration of HCl. .125 mole per decimeter